Welcome to Module 5, Lesson 15, Comparing Fractions with Like Denominators. Now, your parents might be very familiar with this version of comparing. We practiced this when we were students with comparing fractions. So, out of all the ways that you have learned to compare fractions, this is the final one that we're going to study. And I think it's one that you're going to want to use a lot with adding and subtracting fractions later on in this grade and in upper grades. So let's get started. Take a look at the two fractions I have written and drawn here. On the left you can see I have a third, and on the right you can see I have 1/4. Now if we were to want to compare these and to look at drawings, you could look and say, well, you know, it looks like this is more than the fourth. Well, that is true. A third is greater than a fourth, but you can't always trust a drawing. Sometimes the drawing's not done very well, like mine definitely on the right. You can see my lines are all crooked. So you can't always trust that. But you could do something where you find the common denominator of both of these. Now, denominator is the number that goes under on the fraction, and right now they're not in common. If they were in common, it'd be really easy to compare, right? Like, it's really easy to say that 1/12 is definitely smaller than 2/12. If you have only one of an object versus two of an object, well, then the 2 is definitely more. But when the denominators are different, it makes it more difficult. So, you make them the same. Now here's what I'm going to draw. I'm going to just do a little drawing to make them the same. So, the first fraction's cut into thirds. What I'm going to do is I'm going to apply those thirds to the drawing on the right, to the other fraction. I did make two vertical lines, so now that it is turned into twelfths. Now the number on the right, the 4, was fourths, so I'm going to apply the fourths to my drawing on the left. So you see, you just kind of took the denominators and applied them to one another. What this did was find a common factor between a 4 and a 3. So now both sides are 12ths. If you count those boxes, you can see that there's 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? And on this left side, there are 4 shaded out of 12. And on the right side, there are 3 shaded out of 12. So 1/4 is the same as 3/12, and 1/3 is the same as 4/12. But now you can compare 4/12 versus 3/12, and 4/12 is just a little bit larger. Okay, so I demonstrated that for you in a drawing, but there's also some multiplication that's happening there. So 1/4 or 1/3 and 1/4. We know which one's larger already, but for some way, I drew a picture and got 12s on the bottom. I made 12ths. I did that by multiplying the numbers by a factor that would make them both meet at the same number. That one method I did was multiply by their opposite, or their counterpart. So the 3 gets multiplied by the 4. I got the 4 from over here. So whatever you do to the bottom, you have to do to the top. And then on the other side, I multiplied the 4 by 3's. Now where did I get the 3's? I got the 3 from the third over here. So you just choose the opposite numbers. 3 times this side, 4 times this side. Okay? And then what do you get? You get 4/12 and 3/12. And 4/12 is bigger than 3/12. Okay? The goal is to make the denominators match. And you can use this principle where you multiply the opposite, 3 times 4 and 4 times 3, to make the same number in the bottom, right? Because if you do 5 times 7 and 7 times 5, you're going to get the same number. If you do 2 times 4 and 4 times 2, you're going to get the same number. It doesn't always have to be like this. What if we were doing 1/3 versus 3/6, and I wanted them to be the same? Well, then I only have to change this side to make it 6. Now Oops, sorry about that. That's a 2. Ugly 2. Sorry about that. It's driving me crazy. I need it to look at least decent. Alright, so I have 2/6 versus 3/6. Aren't my denominators common? Can I say that 3/6 is more than if I only had 2/6? Alright, so there's multiplication happening as well as demonstrating with a drawing. To go ahead and do both on the first page. So if you look at C, I've already drawn 2 boxes. You're going to want to draw 2 boxes. Just as a principle, when I talk to my students, if you do have to compare 2 fractions, I still like cross-multiplying to make sure I'm right. So 4 times 8 crosses to each other to make 32. And 6 times 5 crosses to one another to make 30. So I definitely know the left, 32, is going to be greater than the right. So I can go ahead and place that answer in there. But I have to show it. So what you're going to do on the 2 boxes is you're going to first draw lines on the left to make them 6, 4, 6. And you can do those by making your vertical lines. Got 6 there. We want to shade in 4 of them. Just try to do that quickly. So there you go. And on the bottom one, it's kind of interesting. You're going to want to go ahead and draw the next lines horizontally, the other direction. So we have 8ths. Wow. That's going to be hard to draw. There's 4ths, and if you cut each 4th in half, you'll have 8ths. Whew. And I'm going to want to shade how many? 5 of them, because I have 5 8ths. So there you have it. You should take some time to draw your 5/8. Now you're going to want to apply the denominators to one another, the splitting up of that space, that fraction. So on the top we had 5ths, right? So on the bottom, 6. On the bottom you need to have 6 as well. So you see I'm going to draw these lines going down to make sure I have 6. And then if you look at the top, we're missing our 8ths. There was 8ths on the right fraction. So you're going to want to make 8ths going across here. So they're going to be really small again. Wow, I didn't even split that up very accurately. And now if you look at the square pieces, if you look at the rectangles, you'll see, wow, that really messed me up. You'll see that the pieces are the same, but there's a different amount of shaded pieces. So how many pieces did I make? You can count them all, and you can count the shaded ones, or you could use the multiplication. So here's how we're going to use the multiplication. The 4/6 on the left gets multiplied by 8ths. We split it up into 8ths, and we get 32 48ths. And the 5/6 on the right, we multiply 5/6, I said? 5/8, right? We multiply that by the 6ths on the left, and we get 30 48ths. So if I were to count all the shaded pieces here, there would be 30. If I were to count the shaded pieces here, there would be 32. And didn't we say that the left side would be larger? Yes. Alright, you're going to need to do that on the rest of these. But on the back, they just want you to go ahead and compare with multiplication. Use multiplication. So you have to show me your work. What did you change the denominators to? Okay, so the 2/3 here gets multiplied by 4ths, it'll become 8/12. And if the 2/4 on the right get multiplied by 3rds, then it becomes 6/12. 8/12 is definitely bigger than 6/12. Alright? On C, I would only double the 5/4. Because if we double the 5/4, didn't we create 10/8 compared to 9/8? 10/8 is larger. So you do have to show your multiplication. On B, multiply the 2 here, multiply it by 7ths, right? And we got the 7ths because of these 7ths. And the sevenths you're going to want to multiply by 2's because there's a 2 on the other side to make them both 14s on the bottom. Now for the last one, and then we will stop the recording. You could use any method. So if you like making the denominators the same, like you want to triple this one to make it 6/9 versus 8/9, well, that's great. But if you like cross multiplication and you just want to say 5 times 4 is 20 and 7 times 4 is 28, 28 is bigger, this side's bigger, then please feel free to go ahead and do that. Alright, if you have any more questions about comparing fractions with like denominators, see me and I'll be glad to help.